To factor a quadratic trinomial to form ax squared plus bx plus c, this time where a is not equal to 1. So the coefficient of the x squared this time will no longer be equal to 1. And there is no common factor. We need to rewrite the middle term, that bx, we need to split that into two terms. And when we split that bx into two terms, the coefficients of those two terms, the numbers in front of the x, will be factors of AC. So they'll multiply together to get what A times C is, and they'll have a sum of B. They will add together to get the coefficient of this x. So once again, when we split this bx into two terms, the coefficients of the x's will multiply together to get what A times C is, and add together to get B. This process is called factoring by grouping. So we're going to start with this one, 2x squared plus 11x plus 12. And first thing you notice is there is a coefficient of x squared that is no longer 1. Also, there is no common factor that you could factor out. So we need to do this process of factoring by grouping. We're still going to factor this into two binomials, but since there's now a number showing in front of the x squared, we have to do factoring by grouping. So we're going to split this 11x into two terms. The coefficients of those two terms, the numbers in front of the x, will multiply to get what 2 times 12 is, and add to get this middle coefficient of 11. So they multiply to get 24, and they add to get 11. The numbers in front of the x's when you split this 11x into two terms. So once again, they multiply to get 24. So think of factors of 24. You have 24 and 1, 12 and 2, 8 and 3, 6 and 4. Which pair can you put together to make an 11? Would be 8 and 3. So we're going to split that 11x into 8x and 3x. Everything else stays the same. We still have the 2x squared out front, and we still have the plus 12 on the end. But we're splitting that 11x into two terms. Their coefficients, the 8 and 3, multiply to get what 2 times 12 is. So they multiply to get 24, and they add to get this middle coefficient of 11. 8 and 3. So it's 8x and 3x is what we're splitting that 11x into. Now the reason this is called factoring by grouping is because of this next step. We're going to group these first two terms together, the 2x squared and 8x, and factor out the common factor. Then we're going to group these last two terms together, the 3x and the 12, and factor out the common factor there. So the 2x squared and 8x, the common factor of 2x squared and 8x is 2x. So we're going to factor a 2x out of those first two terms. Now when you factor a 2x out of those first two terms, you're dividing each term by 2x. So 2x squared divided by 2x is x, and 8x divided by 2x is 4. Then again, group the last two terms together, the 3x and the 12, factor out the common factor there, which is 3. So if you divide each term by 3, 3x divided by 3 is x, and 12 divided by 3, that is 4. So we group the first two terms together, factored out a common factor of 2x. Group the last two terms together, factored out a common factor of 3. Notice we have x plus 4 in parentheses. Both sets of parentheses we have x plus 4. You have to get the same thing in the parentheses for this process to work. If you don't get the same thing in the parentheses, then either you made a mistake or it doesn't factor. So since we do have the same thing in the parentheses, the x plus 4, that is the next step, is to factor out what's in the parentheses. So really you have two terms here. The term on the left, 2x times x plus 4, and the term on the right, 3 times x plus 4. We're going to factor out that common factor of x plus 4. So imagine taking that out, erasing it, removing it. What would you be left with? If you removed an x plus 4 from each one of these, you'd be left with this 2x plus 3. And those are your two binomials. X plus 4, remove that, take that out, factor that out. And what are you left with? You're left with this 2x plus 3. So the two binomials that this factors into are 2x plus 3 times x plus 4. Now again, it doesn't matter what order those are in. Multiplication is commutative. You can move it around, doesn't change the outcome. But this 2x squared plus 11x plus 12 factors into these two binomials, 2x plus 3 times x plus 4. And you can check that with the FOIL method distributive property. If you multiply those back together with the FOIL method distributive property, you would get this 2x squared plus 11x plus 12. Factoring by grouping. We're going to factor this expression 4x squared minus 4x minus 3. You see there is a number showing in front of the x squared. You have a 4 in front of the x squared. Also, there is no common factor that you could factor out. So you have to do factoring by grouping. Factoring by grouping, we're going to split this negative 4x into two terms. The coefficients, the numbers in front of the x, when you split that, we're going to multiply to get what 4 times negative 3 is, which is negative 12, and they're going to add together to get this middle coefficient of negative 4. Once again, when you split that negative 4x into two terms, the coefficients, the numbers in front of the x's, will multiply together to get what 4 times negative 3 is, negative 12, and add together to get this middle coefficient of negative 4. So think of factors of 12. You have 12 and 1, 6 and 2, 4 and 3. Which of those can you possibly put together with a negative sign involved, add together to make it negative 4? Once again, 12 and 1, 6 and 2, 4 and 3. Well, the 6 and the 2. And then you have to decide, well, which one's positive, which one's negative, so that when you add those together, you get a negative 4. The 6 is going to be negative. So we're going to split that negative 4x into negative 6x and 2x. Take that middle term, negative 4x, split that into these two terms, negative 6x and 2x. The coefficients, the numbers in front of the x's, multiply together to get negative 12, what 4 times negative 3 is, and add together to get this middle coefficient of negative 4. Now, the reason this is called factoring by grouping is because of this next step. We're going to group those first two terms together, the 4x squared and the negative 6x, and factor out the common factor. Then we're going to group these last two terms together, the 2x and negative 3, and factor out a common factor there. So the 4x squared and negative 6x, a common factor of those two terms, would be 2x. But if you look at these last two terms, 2x and negative 3, you might say, well, there is no common factor. But there is. You can always factor a 1 out. So we're going to factor 2x out of those first two terms. If you factor 2x out of those first two terms, divide each term by 2x. 4x squared divided by 2x is 2x. And negative 6x divided by 2x, that is negative 3. And then group the last two terms together. Again, I said it looks like there is no common factor that you can factor out, but you can always factor a 1 out, especially to make this work the way you want it to. So if you factor 1 out of those last two terms, divide each term by 1, you end up with 2x minus 3 again in parentheses. Remember, you have to get the same thing in the parentheses, the 2x minus 3, in order for this to work. If you don't get the same thing in the parentheses, you either made a mistake or it doesn't factor. Because that is the next step, is to remove what's in the parentheses. Factor out what's in the parentheses. Because you have two terms here, a term on the left and a term on the right. So take out the 2x minus 3 out of those two terms, just like erasing it with your eraser. What are you left with? You're going to be left with this 2x plus 1. So factor 2x minus 3 out of those two terms, you're going to be left with this 2x plus 1, and that creates the two binomials that this factors into. Again, it doesn't matter what order these are in. Multiplication, you can move it around, doesn't change the outcome. So this 4x squared minus 4x minus 3 factors into 2x plus 1 times 2x minus 3. You can check that with the FOIL method distributive property, multiply those back together. You will get what you started with. I'm going to take this 2x squared minus 11x plus 15 and factor that into two binomials. Again, the coefficient of x squared is something other than 1, and there is no common factor to factor out. So we're going to do factoring by grouping. We're going to split this negative 11x into two terms. The coefficients of those two terms, the numbers in front of the x, will multiply together to get what 2 times 15 is. So they multiply together to get 30, and they add together to get this middle coefficient of negative 11. Now forget the negative sign right now. Just think of two numbers that multiply to get 30 and add to get 11. And then we'll worry about the negative or negatives later. So factors of 30 will be 30 and 1, 15 and 2, 6 and 5, 10 and 3. Which of those can you put together? Which can you pair together? When you add them, you get an 11. It'd be the 6 and the 5. Now, when you add those together, you're going to get a negative 11. So that tells you that they'll both be negative. So negative 6 and negative 5 is what you'll split that into as far as the coefficients. So again, multiply to get 30, add to get negative 11. Those two numbers are negative 6 and negative 5. But you're splitting this negative 11x. So you're going to split that into negative 6x and negative 5x. Quick check of that. Put those back together, negative 6x, negative 5x, that does make negative 11x. Also, negative 6 times negative 5, that is what 2 times 15 is, that's 30. Now, factoring by grouping. Because of this next step, group those first two terms together. 2x squared negative 6x, factor out a common factor of 2x. Then group the last two terms together, negative 5x and 15. The thing here is, remember, you have to get the same thing in the parentheses. So when you factor 2x out of those first two terms, divide each term by 2x. 2x squared divided by 2x is x, and negative 6x divided by 2x is negative 3. Now those last two terms, you might think, well, I'll factor a 5 out, because that's the greatest common factor. Well, that doesn't really work with what we want to do here. We want to get the same thing in the parentheses. So instead of factoring a 5 out, you have to factor a negative 5 out in order to get the same thing in the parentheses. So we're going to factor a negative 5 out of those last two terms. Divide negative 5x by negative 5, that's x, and divide 15 by negative 5, that is negative 3. So notice we have the same thing in the parentheses. X minus 3 is in the parentheses on both those terms. That's important because that's the next step. We're going to factor that out, take that out, remove it, erase it, whatever you think of. We're taking an x minus 3 out, and when you do that, you're going to be left with this 2x minus 5, and those are the two binomials. X minus 3 times 2x minus 5, or 2x minus 5 times x minus 3. So this 2x squared minus 11x plus 15, when we do factoring by grouping, because you have a number showing in front of the x squared and there is no common factor to factor out, factoring by grouping makes this into 2x minus 5 times x minus 3. What's the complete factorization of 2x squared plus x minus 15? Now, a lot of people, when they see multiple choice like this, they want to go through and multiply each one using the FOIL method or distributive property. Well, yes, that will work, but also that eats up a lot of time, especially if your answer you're looking for is the last one. You're still better to do factoring by grouping. You're much faster that way, more efficient. 2x squared plus x minus 15. So when I go to factor this, I notice I have a 2 in front of the x squared. That's something other than 1. Also, there is no common factor to factor out. So I'm going to do factoring by grouping. I'm going to split this x into two terms. The coefficients of those two terms, the numbers in front of the x, will multiply to get what 2 times negative 15 is. So they multiply to get negative 30, and they will add to get this middle coefficient of 1. So think of two numbers that multiply to get negative 30 and add to get 1. Or just think of 30, factors of 30. You have 30 and 1, 15 and 2, 10 and 3, 6 and 5. Which of those can you possibly put together to make a 1 with maybe a negative sign involved? It'd be the 6 and the 5. So two numbers that multiply to get negative 30 and add to get 1. Now think about your negative sign. The 6 and the 5, they're going to add together to get a 1. Which one is positive? Which one is negative? Well, if you're adding a 6 and a 5 to get a 1, the 5 has to be negative, the 6 has to be positive. So we're going to split that x into 6x and negative 5x. Once again, split this x into these two terms, 6x and negative 5x. The 6 times negative 5, that's what 2 times negative 15 is. That's negative 30. And the 6 and negative 5 added together, that makes the middle coefficient of 1. We're going to group these first two terms together, the 2x squared and 6x, and factor out a common factor. Then we're going to group the last two terms together, negative 5x minus 15, and factor out a common factor there. Remember, especially on those last two terms, you have to get the same thing in the parentheses for this to work. So if we factor a 2x out of these first two terms, divide each term by 2x. So 2x squared divided by 2x is x, and 6x divided by 2x, that is 3. Then group the last two terms together. Remember, you have to get the same thing in the parentheses. You have to get an x plus 3 in parentheses. If you factor a 5 out of those last two terms, it's not going to do it. You would have negative x minus 3 in parentheses. We need x plus 3. So factor a negative 5 out of those last two terms. Divide each term by negative 5. So negative 5x divided by negative 5, that's x. And negative 15 divided by negative 5, that is 3. Notice we have the same thing in the parentheses, x plus 3. That's the next step, is to factor that out. Take that x plus 3 out of those last two terms. So if you take that x plus 3 out of those last two terms, imagine erasing it with your eraser, what are you going to be left with? You're going to be left with this 2x minus 5. So if you take that x plus 3 out, you're left with 2x minus 5, and those are the two binomials. 2x minus 5 times x plus 3, and looking at the answers up here, not quite yet. Looking at the answers up here, 2x minus 5 times x plus 3, that is letter B. What is the complete factorization of negative x squared plus 3x plus 28? First thing I notice here is the coefficient of x squared is negative. Also, the coefficient of x squared is negative 1. So the first step here is to make that x squared positive. To do that, we're going to factor a negative 1 out of all three of those terms. Now, when you factor a negative 1 out of all three of those terms, you're just changing all the signs. You're just dividing each term by negative 1. So if you divide each term by negative 1 or change all the signs, take a negative 1 out, you're going to have x squared minus 3x minus 28 in parentheses. Now, this x squared minus 3x minus 28 in parentheses, that factors into two binomials. Notice the leading coefficient is 1. This is one of the easy ones. The first terms of those two binomials would be x. The second terms multiply to get negative 28 and add to get negative 3. So you have to think of two numbers that multiply to get negative 28 and add to get negative 3. Those two numbers would be negative 7 and 4. So completely factored, we factored a negative 1 out. You really don't need to write a 1, just the negative sign will do. So it's the negative of x minus 7 times x plus 4. Back to the factoring. This x squared minus 3x minus 28 had been talking about factoring by grouping. Really don't need to go through that process here. But you could if you wanted to. I don't know why you would, but the factoring by grouping on that would still work. But when the coefficient of x squared is 1, all you have to do for those second terms is think about what two numbers multiply to get negative 28 and add to get negative 3. In this case, negative 7 and 4 worked. The answer to this one is letter I. What is the complete factorization of 6x squared plus 9x minus 6? Always look for a common factor that you could factor out first before you do anything else. So the 6x squared plus 9x minus 6, a common factor to those three terms, it's not 3x, it's just 3. There is no x attached to the 6. So it's just 3. We're going to factor 3 out, divide each term by 3. So 6x squared divided by 3 is 2x squared. 9x divided by 3, that is 3x. And negative 6 divided by 3, that would be negative 2. Now, we're going to factor this into two binomials. Notice the coefficient of x squared this time is 2. Also, there is no common factor to factor out because we already did that. So we're going to factor this by grouping, this 2x squared plus 3x minus 2. We're going to split that 3x, split that middle term into two terms. Their coefficients, the numbers in front of the x's, will multiply to get what 2 times negative 2 is, negative 4, and they'll add to get 3. So you need two numbers that multiply to get negative 4 and add to get 3. So factors of 4, simply 4 and 1, 2 and 2. Which of those can you put together to make a 3? The 4 and the 1. And then you have to decide which one is positive, which one is negative. The 4 and the 1, which one's positive, which one's negative, so that when you add those together, you get a positive 3. Well, the 4 will be positive and the 1 will be negative. So we're going to split that 3x into 4x and negative x. Still have a 2x squared out front. Still have a negative 2 on the end. That's in parentheses, and we still have a 3 out in front of all this. Common mistake people would make here is as they're going through this, they drop the 3 off, they'd forget about it, and they just end up factoring this. So we still have that 3 out front, and we split that 3x into 4x and negative x. Still have the 2x squared out front there, and negative 2 on the end. So now we're going to group these first two terms together, 2x squared and 4x, factor out a common factor of those first two terms. Common factor is 2x. So we factor 2x out of those first two terms. 2x squared divided by 2x is x, and 4x divided by 2x, that is 2. Now the last two terms, the negative x minus 2, you have to get the same thing in the parentheses for this to work. So we have to end up with an x plus 2 in parentheses. So we have to factor negative 1 out. If you divide each term by negative 1, negative x divided by negative 1 is x. That's what we want. And negative 2 divided by negative 1 is 2. So we have what we wanted, x plus 2, the same thing in both sets of parentheses. Because that's the next step, is to take that x plus 2 out, remove that x plus 2. Imagine you're erasing it. Don't forget you still have the 3 out in front of all this. But if you take that x plus 2 out of each of those two terms, you would be left with this 2x minus 1. So factor that x plus 2 out. We still have that 3 out front. But when we factor that x plus 2 out of these two terms, we're left with this 2x minus 1. And those are the two binomials that this 2x squared plus 3x minus 2 factors into. So completely factored off after all that work is 3 times 2x minus 1 times x plus 2. You can see that is letter A. If you want to check that, you could use the distributive property to 3. That's one way to do it. And then you'd have two binomials, multiply those back together. You would get what you started with. Or you could do the FOIL method distributive property with these two binomials first, and then distribute the 3 through that. You would still get what you started with. So completely factored 6x squared plus 9x minus 6 is this 3 times 2x minus 1 times x plus 2, letter A. A perfect square trinomial is the square of a binomial. So trinomial has 3 terms, binomial has 2 terms. An example, x squared plus 10x plus 25. That is a perfect square trinomial. Notice the 2 terms on the end, those are perfect squares. X squared and 25, those are perfect squares. This would factor into x plus 5 times x plus 5. You could also write that as the square of x plus 5. So if you square x plus 5, if you multiply that by itself, and by the way, here's a very common mistake. When people see this x plus 5 squared, they think you just square the x and square the 5, get x squared plus 25. Obviously, you can see that's not what you would get. When you square anything, you multiply it by itself. So if you see x plus 5 squared, that means you're going to multiply that by itself, x plus 5 times x plus 5, and you would get x squared plus 10x plus 25. But what we're talking about here is factoring. This x squared plus 10x plus 25, that is what's called a perfect square trinomial. That factors into x plus 5 times x plus 5, which could be written as x plus 5 squared. There are two forms to a perfect square trinomial, depending on the signs. A squared plus 2ab plus b squared, that is one form. That factors into the square of a plus b, or the quantity a plus b squared. The other form, a squared minus 2ab plus b squared. That factors into a minus b times a minus b, or the square of a minus b, or the quantity a minus b squared. Notice the difference between these two forms. First of all, notice what they have in common, the a squared and the b squared. You have perfect squares on the ends of each one of these, and then in the middle you have plus 2ab on that one and minus 2ab on this one. So the only difference here is the sign in the middle, plus or a minus. So this x squared plus 10x plus 25 up here, that is in the form of a squared plus 2ab plus b squared. That factors into a plus b squared. So how would you go from that using this form to this answer? Well, a squared is x squared, so this a would be the square root of x squared, and that is x. And then if b squared is 25, the number that goes in the b spot here is the square root of 25, and that is 5. Put it in parentheses and square it. It's going to be x plus 5 squared. Let's start with this one, 4x squared minus 20x plus 25. First look on that, make sure there is no common factor that you could factor out, which there is not. But also notice 4x squared is a perfect square, 25 is a perfect square. Also think in terms of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Think about these as a's and b's. If a squared is 4x squared, a would be 2x. And if b squared is 25, b would be 5. So you have a 2x, a 5, that's 10x. If you multiply by that by 2, that'd be 20x. So this is in the form of a squared minus 2ab plus b squared. So it is a perfect square trinomial. Once again, it's in the form of a squared minus 2ab plus b squared. This will factor into a minus b squared. Recognizing it's a perfect square trinomial is the hard part. Factoring it, that's the easy part. Because if a squared is 4x squared, what goes in the a spot here is the square root of that. The square root of 4x squared would be 2x. If b squared is 25, what goes in the place of the b here is the square root of 25, which is 5. And since it's in the form of a squared minus 2ab plus b squared, I'm going to put a minus sign between those terms. 2x minus 5 squared is what that factors into. Now you could check that, multiply 2x minus 5 by itself. You would get this 4x squared minus 20x plus 25. Really, this is an option. You really don't have to factor in this way. You could still do factoring by grouping. You could go that route. This is somewhat of a shortcut. So if you recognize you're looking at a perfect square trinomial, and you know these patterns and how this factors, then go ahead and save some time and factor it this way. But factoring by grouping that we talked about earlier will still work here. Once again, 2x minus 5 squared, that's the same thing as 2x minus 5 times 2x minus 5. Keep that in mind. A lot of mistakes are made. When people see that, they just square each term. It's multiplying it by itself. When you square anything, you're multiplying it by itself. Next one up, 81z squared plus 36z plus 4. That is a perfect square trinomial because you have perfect squares on the ends, 81z squared and 4. Those are perfect squares. And again, thinking about a and b, if a squared is 81z squared, a would be 9z. And if b squared is 4, b would be 2. So 9z times 2, or in other words, a times b. 9z times 2 is 18z multiplied by 2 is this 36z. So this fits the bill for the perfect square trinomial. And this is in the form of a squared plus 2ab plus b squared. So this is going to factor into a plus b squared. Factoring is the easy part. Recognizing it's a perfect square trinomial is the hard part, but factoring is easy. Once you recognize it's a perfect square trinomial, it's all plus signs, you're going to have a plus sign between the terms. This a, again, is the square root of 81z squared. That's 9z. What goes in the b spot here is the square root of 4. That's 2. So you just do 9z plus 2 squared. Remember, that's 9z plus 2 times 9z plus 2. So again, recognizing they're in the form of perfect square trinomials, it's a little tricky. It takes a little practice. But the factoring part, that's easy. Once you know it's in the form of a squared plus 2ab plus b squared, it factors into a plus b squared, or a squared minus 2ab plus b squared. It's a minus b squared. These two very similar. The only difference is a plus and a minus sign. That is how you factor a perfect square trinomial. Factoring a difference of two squares, a squared minus b squared. That is a difference of two squares. You have two perfect squares with a minus sign between them. That is a difference of two squares. One of the easiest things there is to factor. So first thing is to recognize you're looking at a difference of two squares. Difference means subtract. Squares means you have perfect squares on the end. So difference of two squares, you have a squared that's a perfect square, b squared is a perfect square. The minus sign between them means that is a difference of two squares. That factors into a plus b times a minus b. Very easy to factor. Just take the square root of a squared, that's a, that's the first term of each binomial. The square root of b squared is b, that's the second term of each binomial, and then you do a plus and a minus. Very, very easy to factor. 25x squared minus 49, that is a difference of two squares. 25x squared is a perfect square. 49 is a perfect square. It has a perfect square root. And you have a minus sign between them, so that is a difference of two squares. That's going to factor into, if this is, think of this as a squared minus b squared, that factors into a plus b times a minus b. Real easy to do, just take the square root of 25x squared, that's going to be 5x, so what goes in the a spot is 5x. And the square root of 49 is 7, what goes in the b spot is 7. So it'd be 5x plus 7 and 5x minus 7. So that difference of two squares, 25x squared minus 49, simply factors into 5x plus 7 times 5x minus 7. Again, recognize it's the difference of two squares. Take the square root of the first term. The square root of 25x squared is 5x. That's the first term of each binomial. Take the square root of the last term, the square root of 49. That's the second term of each binomial. Do a plus and a minus, and you have it. 5x plus 7 times 5x minus 7. If you multiply those back together with the FOIL method distributive property, you would get where you started with, that 25x squared minus 49. Now, could you do factoring by grouping on this? I don't know why you would, but you could fill in with a 0x there. You could put a 0x between those terms and still do factoring by grouping, but believe me, that's wasting some time. I'm going to factor this negative 6z squared plus 600. Now, notice your squared term has a negative coefficient. So we always want that squared term to be positive. Also notice 6 is a factor of this 6 and also the 600. So instead of just factoring a 6 out, we want the z squared to be positive. We're going to factor a negative 6 out. So take a negative 6 out of those two terms. Divide each term by negative 6. So negative 6z squared divided by negative 6, that's z squared. And 600 divided by negative 6, watch your signs, that's negative 100. So factor negative 6 out, you have negative 6 times z squared minus 100. Now that in parentheses. Z squared is a perfect square. 100 is a perfect square. That is a difference of two squares. So that's in the form of a squared minus b squared that factors in a plus b times a minus b. Really, all you're doing is taking the square root of z squared, that's z. Take the square root of 100, that's 10. Then do a plus and a minus. So it'd be z plus 10 and z minus 10 is what that factors into. So you have that negative 6 out front. Don't forget that. The z squared minus 100, that difference of two squares, factors into z plus 10 times z minus 10. So completely factored, negative 6z squared plus 600 is negative 6 times z plus 10 times z minus 10. What is the complete factorization of 5x squared minus 20? It's one of these. Now a lot of people, they see multiple choice and they think, oh, I'll just multiply those together using the FOIL method distributive property. Go through each one until I get 5x squared minus 20. You're wasting your time. You don't need to do that. You're much more efficient, much faster factoring it the way you were taught. So the 5x squared minus 20, always look for a common factor that you can factor out before doing anything else. 5 is the common factor of those two terms, so we're going to factor a 5 out. Divide each term by 5, so 5x squared divided by 5 is x squared, and negative 20 divided by 5, that is negative 4. Now look at that x squared minus 4. That is a difference of two squares. You have x squared is a perfect square, 4 is a perfect square with a minus sign between them. That is a difference of two squares. that's going to factor into x plus 2 times x minus 2. So the first term of those two binomials would be the square root of this first term, the square root of x squared. That's x. The last term of those two binomials would be the square root of this last term, the square root of 4 is 2. Then do a plus and a minus. So that 5x squared minus 20 completely factored, that is 5 times x plus 2 times x minus 2, which in this case is the letter C.